if you've saved your questions and answers. Also, one thing I want to point out, if you go to your app that you downloaded for your Android or your phone, you can rate this session as well. So we definitely want to make sure you do that before you leave. But at this time, we can take questions from the audience. Does anybody have any particular questions for these guys in the back?
So for Purdue, okay, so for Purdue, how did you go about justifying putting a system like this in place when you probably had hundreds of thousands of dollars worth of deferred maintenance that you probably knew about that you haven't gotten to?
We had developed a very strong relationship with our treasurer, who got there 6 months before I did, who came from the private sector. And he's looking at, you have to do business planning, long-term assessments, which we did. But what would surprise you is what we have done for all 5 utilities is way under $100,000 total. By the time we're fully up and running, I think we're going to probably go over 60, or maybe over 50, less than 60. So in a budget that I have of purchase utilities of $32 million, and an operating recurring budget of another 10 plus, and an R&R budget of at least 8.5 and up there, if I can't find a way to reallocate $50,000, then they should go find another manager. So it was really a choice on my part, because they're not controlling down to that level to reallocate those funds. Does that kind of answer your question?
Just a follow-up to that. So it does. Good news is you have that control. If you created savings, so for instance, you're able to drop your utility usage down by X%, did that go back into your budget, or did that go to the treasurer's budget?
The original plan was for the money to be rolled into our capital deferred maintenance plan. The challenge, so if we reduced our purchase utility by $1 million, that was supposed to go into this funding for continued deferred maintenance. The problem that I had was, after getting there and seeing what we could change with, like Raul said, no cost, we ended up generating surpluses that made their head spin. So in 3 years, we turned back something well over $12 million in unspent purchase utilities. And structurally, I said, you need to reset the purchase utility budget from 36 to 32, because why do I want to just keep creating a surplus other than it's rolling into my deferred maintenance? At the same time, I did a 25-year condition needs and identified what our projects are. And yeah, in the far distant, it's iffy. So I went back and I said, so if you guarantee me the money, you can take the surplus and do with it whatever you want. And he looked at it and said, works for me. So he did. And then as we defined our long-term capital needs and deferred maintenance, there's only so much you can do and keep a power plant running. So we identified a timeline which allowed him to levelize his capital expenditures. And in 3 months after I got there, the question he posed to me is, what do you care where the money's coming from if you get the money? And I said, I don't. But you have to commit to giving me the money, otherwise we won't give you the savings. So I'm very fortunate with a vice president of facilities that kind of lets me do my job, a treasurer who really likes it because he gets the credit for all these surpluses, and a president who says, I want to maintain student affordability, so if we cut costs, we're not raising tuition. And now we're up, I think, to year 6 without raising tuitions, student residence fees, housing fees, dining fees, or any other student fees. That's really an accomplishment without sacrificing service.
So great. So can you go do that at my 2 daughters' schools so that I can not have my fees raised?
Seriously, I worked at a different organization with Russ's group to implement fault detection, and it will run out a full 10 years. It's $1 million contract. There I had to show the value proposition. How are we going to recover that money? NYSERDA funded part of it, and they're showing the savings associated with that fault detection. But what the problem is, they're not implementing the corrective action to gain those savings. They're doing other work that's not a priority. And I still have a lot of friends there after 11 years. That's not a priority. And they're having a challenge making that who gets to control the money and where do you prioritize your resources. It's possible to do things. Just give them my card or number, the universities. I have 4 children. They all went through college. I am way beyond that. So you have my sympathies and empathy.
Actually, I wonder if Russ could comment on the fault detection aspect that was just mentioned. I think that's one of your areas of expertise.
Well, this is an area that we've been pioneering, and we started with Microsoft to do their campus, and it's running about 180 buildings right now. They had a $60 million electric spend. They've been able to reduce that by 22%, about 53 megawatts down about 43 megawatts, sustaining that. So what is fault detection? It's really expert system taking the building whisper information and creating rules that could be layered on top of real-time information. So this whole fault detection approach is, we've been applying this at a number of campuses and hospitals, and combined with machine learning, you can get the demand response, and you can get the operational building systems where you're doing continuous commissioning and provide continuous savings. So this whole area of fault detection can be applied in oil and gas, in water systems. We're rolling out this capability, creating about 50 rules for Loudoun County water outside of Washington, D.C., largest growing area outside of Washington. And so applying fault detection to mechanical systems could provide a very interesting way of predicting failures and saving and creating uptime.
I jokingly, when we went down our different route, having been down the route with fault detection, mentioned to Russ and his crew, we're just doing fault detection at a building level, rather than the individual unit or asset level. And that gives me a much more rapid introduction at a much lower cost. We did the proof of concept with the reports, and then we showed what the economic return on asset allocation was, and that got their attention saying, whoa, you know, we know where you're going. Now, the next step beyond building fault detection is getting into the fault detection at the granular level within the buildings. And the debate is, how do you implement that in a very rapid timeline to get the returns to keep everybody on board with funding that project, because it's more expensive than what we did. And I think we'll get there. And again, I run water wells. We treat water. We distribute it around campus. I got a resource that I can go to. What are you doing down there? What can we use in fault detection in our system, right? So this sharing of knowledge, like you have at the ARC Forum or elsewhere, really does provide a lot of assets or a lot of benefits to us.
More questions? Any other questions from the back?
I guess I'll ask another one. So who builds your fault detections at Purdue? Do you build them yourself?
We set the rules down for the building level, and then we went to Iconics and said, okay, you're the integrator, aggregator, let's get the data flow going, let's write those rules in the formulas that create the reports that we have there. Part of what we're getting out of it is training of our people on how to write those rules, how to prepare the reports, how to get the addressing so that they go to the right people. So we built that into our program because ultimately we do want to be able to take ownership of that. But we're on a subscription basis right now. I fully expect at some point we're going to move from that, based upon my IT people, into the licensing of the software and everything else for the entire fleet that Iconics has. So we're taking it incrementally, but the numbers just bear it out that it's a wise direction to go with minimal cost.
So at the University of Pennsylvania, it's a campus-wide BAS monitoring system and control system for the entire campus, and the machine learning was layered on top of that, where we're providing information for the demand response. At Purdue, we're doing a cloud, an Azure cloud implementation, taking IoT data from the utilities, pushing that to the cloud, and providing the dashboards and the analytics that helps Al being able to deploy this in other campuses because it's all running in the cloud. And it's a subscription basis versus buying all the software up front. You're simply paying a monthly subscription for that.
One thing to recognize that people lose track of is much of the data that you collect from a meter is often immediately adjacent to data that's collected by a BAS system. And because of our data collection and concentration panels that we have out there, we can pull this information in the format that's needed for the Russ to go out and pull it with the platform that we have. So we're seeing this crossover where when you look at fault detection, it's not just equipment assets and operating ranges of equipment, whether it's on or off. We're getting into the hardcore data on sensors of temperatures, pressures, differentials, things of that nature. So we're seeing the ability or the need to blur those lines. And that's a really, if you can do that, boy, you really can develop some very powerful tools.
So in the first presentation, there was a lot about basically the peak. So you're looking at shaving the peak off. But in the second case, it seems like you're just operating the building as efficiently as you possibly can. So one case, it's an economic dispatch, and the other is economic but based on a opportunity with the utility or to cut costs with respect to the utility. I assume there must be a demand charge. So in either case, if you were going to interface with the utility now for grid services, how would it change what you're currently doing? So in the second case, is there any opportunity at all? The building's already being economically managed overall, so how would you actually put grid services into that case? And in the second, or in the first, how do you actually interact with the utility to provide so it looked like they're providing the prediction of the peak, but how are you providing back to them what the opportunity is? How does that work with respect to the utilities? So it's kind of two different.
Okay, so Raul will answer first, and then I'll.
Sure, that's a very good question. So it's basically in Al's case, it's really looking at how do we operate the entire campus efficiently, and so you're trying to remove by spotting faults, you're trying to remove inefficiencies by really looking at what's the temperature drop off with the steam and so on, right? So that is just in any natural very complex, messy system that's built over the years. These inefficiencies are, initially low-hanging fruit, and then after that you have to go through your retrofits and have a longer-term ROI. And versus in the case of the peaks, it's saying no matter what, whether you're operating efficiently or not, you still have a baseline. And so efficiency is basically saying that your baseline, instead of being on this threshold, is slightly lower. And so you can think of efficiency in two parts. One part is really removing waste, and that could be structural, that could be equipment related. And the other part is, with retrofits where you're fighting physics, which is where the improvement in a high efficiency new equipment is going to get smaller and smaller and basically saturate after some point. So, but now with these peaks over here, you want to basically do the baseline, lower your baseline at all times. But since this volatility has started banging so much, and there has been much more volatility, you can even see in the past winter, the extreme cold that we had, and I could see in my home bill the big spikes that are there, right? So with increased volatility, you have to expand your energy management portfolio to basically bound and minimize the financial risk that you're exposed to with this volatility. So while the grid is giving you a participation and a program to participate in, there is this penalty side of the participation that many large customers don't want to participate in because they do not have the visibility into how much flexibility they have. And so essentially what we are arguing here is that we can provide you these energy X-ray goggles to tell you what's going to happen in the next couple of hours and how you can actually control your peak. So you can decide what level of participation you want with the utility, and as Russ was mentioning, this would be a layer above your efficiency programs, your fault detection management programs of doing this peak management over here. So then we are essentially trying to make sure that you don't get too exposed to this volatility. And so I'll let
Regardless of regulated or unregulated utility state, I've worked in both. I've participated in demand reduction strategies in both, where what we do is we look at where can we eliminate the inefficiencies as quick as possible to gain the dollars. But we do look at demand reduction. Our campus is a microgrid. The utility company, which is Duke Energy, is running a microgrid. We're just a distributed generation that doesn't feed back into the grid. They deliver power to us. The relationship on demand reduction, or power share agreements that they call it in the Duke regulated utilities, is we commit to a certain reduction. Now, we can do that by spinning up our generators if we wanted to, if they're not running at capacity, adding another standby generator, number 2 fuel oil fired generator, reducing demand, so we can take actions to increase or decrease our consumptive load from the grid. So we are functionally acting as a microgrid with communications which right now are not automatic or auto-generated, that are phone calls. And I know S&C's here, and they're moving a lot into microgrids, and what we're looking at is we need to look at our campus more as a microgrid, right? So that we can dispatch equipment and assets to minimize our demand, and then we need to bake what we're doing into the overall Duke Energy of Indiana process of how they're trying to manage their transportation, distribution, and consumption in a broader area. And that's the one where I think there's a lot of value to partnering with universities looking at that, but we're not the experts in microgrid. We run one, but we're not the experts in microgrid. The guy at the end of the table leads microgrid systems for S&C. And we use S&C and ABB and G&W switches. We're starting to tap into those people saying, okay, what are you doing out there? What are we doing? And we've talked about that with S&C in the past of we really need to somehow bring all the pieces together, preferably in an open platform, so that we can convey the information without all sorts of proprietary restrictions and objections. So we're doing that. And in the past, I was able to define, I took a campus where we would reduce 25% of our peak demand I could drop off. And as the utilities saw how much money I was making, which was about $250,000 a month participating in their plan, they just started ratcheting and bracketing me up or bracketing me down, where I reached a point where I simply couldn't participate, at which point they reset the clock for me. But I think there's some value to understanding the microgrids and the demand response.
Yeah, I really think that we have the expertise here of Chris, and I'd like maybe Chris to explain maybe what are some of the next steps, for Purdue University, and how does Purdue University's microgrid compare to this very innovative microgrid you recently installed for Ameren?
Mm-hmm. Sure. So I think when we look at the overall strategy when it comes to DERs with electric utilities, right? We heard Jason mention it. I think he called it the hairball mess, and what was out in there was that battery energy storage, and we saw microgrids in there as well. If anyone's been following Indiana and their regulatory filings, they'll see that Duke Energy last year submitted a rate case to build a microgrid in Indiana, southern Indiana, part of their territory, and it was approved. So the regulators are seeing that. Yes, we agree. We understand this makes sense. It benefits the community. And I think a similar situation to, if you want to say, to a university and a utility working together would be in Chicago, where we see the Illinois Institute of Technology, who has their own on-site generation, really similar to what Purdue has here, what they described. And the utility ComEd is, they have a community adjacent to that called Bronzeville, and they want to build a microgrid there. So I think we see utilities as they target areas where there's already a strong focus with distributed energy, a large amount of energy, a large power consumer, like the university, and then let's start building around that. So we see it in Illinois, we see it here coming up in Indiana. The reference of Ameren in Illinois, this is located in Champaign, so near the University of Illinois. I think a competitor maybe to both schools here. But the University of Illinois and Ameren, what they saw was the utility goes, we need to be able to show that we're in front when it comes to distributed energy and microgrids. So they took an entire feeder, the utility, a mix of residential customers, commercial customers, some utility assets, some university assets on there. And they said, let's make this whole feeder a microgrid. So what does that mean? Well, it's going to run off of solar and wind and natural gas generation, and it's going to have our utility feed. If there's an outage, it would seamlessly transfer over to run off these distributed energy resources, and when the grid comes back, go ahead and go back. So what they're doing is, if you want to say, give me the kitchen sink, right? Everything that's in it. I want to be able to all these resources. I want to do demand response. I want to have 16 different use cases. So what they try to do is, I want to try to do everything. And then what we're going to do is take what we really would apply to other sites and then go use those throughout their system.
So with Purdue, what we're trying to achieve, or what we've been looking at, is adding another distributed generation asset, some type of electrical generation. Whether we own it or we partner with somebody is yet to be decided. We always have a need for steam. You can throw in gas-fired turbines that have a steam generation rate that's very predictable, and if you've got a use for it, you've now levelized your cost of electricity that the utility company can charge to all the ratepayers. So they're not punished because they're making up a portion of the extra cost to run a 25, a 50 megawatt CHP by the steam sale contract. And in our evaluation, I had some questions about internalization of those resources, but for our scopes and size, we think there's at least 16 opportunities to drop distributed energy generation in and around Indiana at institutions, universities, and industry. And in talking with some of our utility partners and rural cooperatives and everything else, we're seeing congestion and issues on the transmission distribution grid that's out there, localized, that if you can start dropping these in at key locations and produce power at an affordable rate, knowing there's a steam use for going forward 24/7, 365, you can address a lot of capital investment or postpone capital investment on infrastructure on the transmission system. Now that's challenging to have people and regulators understand that, well, okay, yeah, but why should that be factored in? Well, it's an avoided expense. But that places the added burden of microgrid communication, starting up systems, increasing what we need to generate, or if the utility has an excess of spinning reserves because of some legacy plants, hey, can you cut back and take more power from us? And now we get into the economic analysis, and how do we set that up? I don't think we're in the automatic world yet to do those defined transfers of power generation. Starting it, bringing it online, taking it offline, that we can get a lot more automated with equipment. But now we're talking economic business decisions that just aren't going to be put into an automatic transfer switch until somebody says, yep, and the other person says, I agree, and then they hit the button. So I think there's a lot of tremendous opportunity there.
So does that mean when the LMP price goes negative and you're getting penalized for generation, you're not going to automatically shut down yet?
Well, we don't export anything to the grid, which is an interesting benefit to Purdue, or interesting benefit to the utility company, because we seldom produce our maximum capacity. Because we're looking at the price signals. We're looking at what is my base load I committed to? What's my real time? What does it cost me to make? I can play those numbers, and in that realm, I'm really optimizing my cost or my energy dollars, but I can be a resource to the utility company.
Fair enough, but when you put all that DER in, now you're going to become an exporter, and that maybe will come.
No,
Okay.
we're not exporting any power.
Okay, one last question.
Don't want to do that.
Well, it's just a follow-up to what you just said. So is your demand include your generation or not?
58 megawatts is our peak demand. We can produce 40 of the 58, so we're 18 megawatts short. Okay?
But you pay for the demand.
We pay for the demand based upon what we commit on our base load, and there's a demand charge on that base load that we commit for the year ahead. So I'm not going to commit to buy 58 megawatts of power because I know I have a high degree of reliability that I can produce up to a certain threshold, 35 megawatts, 24/7, 365, unless I have a catastrophic failure.
So that's interesting because the utility has to have the capacity to supply you if you can't.
Only on the base load demand that I've committed to buying no matter what. And I'm only committing to buying something 10 to 13 megawatts per hour for the entire year. And where we were was a much higher amount. And when we did the economic asset utilization cost of production analysis, it said, why do we want to commit to that base load when we can make it cheaper or buy real time cheaper? So we shifted down. So all they've committed to is our base load. They're not obligated to deliver our real time. They're not obligated to deliver the energy that we could produce. It's 1/5 to 1/4 of our total peak demand that they are obligated to have spinning reserves to cover.
That's not normal.
Purdue's been generating power since the early 1900s with the CHP, and we're grandfathered in. I think we're one of 8 contracts within the state of Indiana because Purdue existed long before the utilities came in, and they and some other institutions have been able to maintain those very unique contracts.
Yeah, because that is not normal. You would normally pay for the peak of your load that's there, period, regardless of your generation.
I agree, and it's one of those. This is where the regulators really need to be brought up to speed of how do we address these issues and how do we move forward to this grid? Because if we're a resource to the utility company, should we be penalized for being a resource to be able to spin up and generate more power because they can't deliver it into the area because congestion on the wires? You know, it works both ways, and I think we're in a healthy balance with our partners at Duke.
Okay, I'd like to have a final round of applause for our speakers and panelists.